In the previous video, we got a really high-level overview of how the internet works. And now that we know that the internet is composed of a whole bunch of networks, and we showed it right here in this diagram, now we're going to jump into what makes a network, and kind of dissect what happens inside of a network and how all of these networks together make it possible for computers to communicate one with another at a little bit lower level than we did with the internet. For that, we need to understand that a network is made up of a bunch of devices. So if we just break it down to like our local home network that we have, and this one, if you've all set up your home network or been involved in your home network, you'll understand exactly what I'm talking about here. And if you are at least familiar with the devices that are connected to your network, you should be able to piece together how all of this works. And we're going to start out with our computer. Actually, let's just start out at our ISP like we did on that last one, on that last video. And we're going to show our ISP as just a circle right here. And we're going to label it really quick as our ISP so we know what we're talking about here. We've got ourselves our ISP. Now our ISP is how our network gets onto the internet so that all of our devices connected to our home network can get onto the internet. And so let's display some of the devices that we have on our network that we know are connected to our network. And one of the primary devices that's between all of the devices in our network and our ISP is going to be what they call the modem. All right, a modem. It's going to be right there. And the modem, it knows how to speak with the ISP in the way the ISP wants to be spoken with. It contains the username and password and the authentication and everything, your user account, anything that tells the ISP that this is a valid network that is going to be allowed to join their network. So usually this is a physical device inside your home. If you have cable and you're connected to the internet, usually it's a big tall tower that you set on next to your TV or next to the cable connection in your wall, and it has a whole bunch of blinking lights and your cable is connected directly into it. Now, usually built into the modem is another device that we call a router, and the router a lot of times is built into the modem, so it's actually two devices in one. Some networks, some home networks actually, people choose to turn off the built-in router inside of the modem, and they use their own router like a Netgear or a Linksys router, if you've heard those terms before. But most of the time, if you're not super techie, you're not going to be using your own router. You're going to have a modem router combo that was shipped to you by your ISP, by your cable company. Now these two together, the modem takes care of the direct communication with the ISP in the way that they want to communicate. And the router, it's responsible for communicating with the modem and then communicating with all of the devices that are inside of your network. And a lot of times it's a wireless router, or you may have a wired router, or you may have both. And when I talk about wired, we're talking about cables that actually come out of this and connect into a desktop computer, or maybe connect directly into the back of your computer or a gaming console. Otherwise, the majority of your devices on your network are going to be just wireless. They're going to be using a wireless connection to your router and a part of your wireless network. So we may have, mobile phones. You might have several. In my case, we've got 5. My wife, myself, and my kids, we've got 5 of those. So those are their mobile phones. They're all iPhones. And then we have several tablets, Kindle Fires for reading. So maybe I think we've got 3 of those. And then we've got laptops galore. So I've got my iPad, my wife's iPad, and then my Kids, they all have PC laptops for their schoolwork. Now you might think, okay, that sounds about normal. That's about what I've got. But in today's world, some people even have their fridge attached to their network, or their washer and dryer are connected to the network. And all of these devices are connected over wireless to the router. So let's go ahead and show those connections really quick. So your washer and dryer could be connected to the network, your fridge or refrigerator, all of your phones, all of these are going to be connected to the router, and then you've got all of your tablets connected, and then all of your computers connected. And they are all connected to the router in order for the router to take care of taking any requests that come from these computers or these devices, and then making sure that when those requests get sent out over the internet through the ISP to the internet, when the responses come back, the router knows who the request came from, and the response goes back to the correct device. If we didn't have a router, then all the requests going out would look like they're from the same computer, and then when the responses came back, the modem wouldn't know who was the original requesting device, and it might just randomly pick a device to send the response to, and that would be really weird and cause a lot of problems. So the router does a really important job of routing across the network, our local network, all responses that come back, and then also all requests within our network from one device to another, as well as requests that go out through the modem onto the internet as an external network to our network. Again, we're seeing how even with our devices, they actually live on a network. Whereas when we created this first diagram, we kind of saw our computer right here, and we kind of showed that the computer connects to the ISP. The reality is, though, it's the network on which our computer lives or is connected that actually speaks to our ISP. And that would be this example right here. Now, when we talk about the communications that happen between devices within our network, as well as communication outside of our network to our ISP, so any of these communications that go from our modem and then out to the internet, all of these happen over different layers of networking technologies. So you can think of these orange lines as pipelines. And inside of these pipelines are layers of technologies or layers of communications that allow us to send and receive data in different formats and in different ways across the network. And what's that? That is called the ISO or OSI, sorry. It's called the OSI model, and it actually is the layers of technologies that we use in our networks in order to connect computers to each other in order to manage that communication between them. So you want to go ahead and look up the OSI, or the Open System Interconnection Model. And on that, there are 7 layers. Now, this is informational for you. This is not critical for you to understand in order to start using Express and Node to build web applications. But it is something that you should know, especially for job interviews or just to become a better computer scientist. You need to understand these. So we're going to run through these really quickly at a really high level, just so you understand what they're all about and what they're for. Now, layer 1 is the physical connection. Now, those are the cables that actually connect the machines together, and then over which all the network traffic happens. Now, nowadays, we don't necessarily have actual physical cables that connect all the devices. We don't have cables that go to our cell phones, but we do have wireless connections that connect our devices wirelessly. But it's a similar theory as to how that wireless connection happens, and then over the wireless connection, all the rest of these things still happen. Now, the data link, that's the layer 2 that rides on top of the physical. In other words, it's what runs inside of the cable, is going to be the data link. And that's where each machine, each network card, the interface that connects the device to the internet, whether that be your wireless card or your physical network card that a cable is connected into, they all have a unique identifier so that your router and switches on your network can uniquely identify a particular device uniquely from all other devices. And primarily the switches use that. And the switches are in our network diagram that we had up here before. The router in our local network kind of also acts like a switch. And a switch really, it's what just passes information through the network using the, let's go back to our other diagram. The switches that live on the internet are actually what determine what the fastest path is across the internet to get to the location. And it really doesn't really care where things go or how they go there. It just knows the fastest path across the network from network to network or from device to device in order to get the communication to happen. And that's really what a switch is. It's that basic layer that starts to push stuff around the internet in the most efficient manner. Now the network layer on top of that, where we have IP, now IP is the internet protocol. And the internet protocol, if we go back to our diagram, the internet protocol, it stipulates that at the gateway for each of these networks, or if we go back and we look at our, we need to go back one more, there it is. And we look at our network here on our local network, every single device, not only does it have a unique MAC address for its actual physical hardware that connects it to other physical hardware, it also has a virtual unique identifier, which is called an IP address. And you've probably heard of IP addresses as you've been learning about technology or as you've set up your own networks. IP addresses look something like this, 192.168.1.1. This is what an IP address looks like. And the IP address is what allows a router to uniquely identify a device on the network. And every single device on the network is going to have one of these IP addresses. So 192.168.1.2. And you see I'm just incrementing that last number over here as my new IP address. And with each device having an IP address, this router can then create a table of what request came from which device. And then when that request goes out on the internet, when the response comes back, it knows which computer to send that response back to. And that's what this layer is for, the network layer. It uses IPs and routers. Now the transport layer, TCP, UDP, and port numbers. The transport control protocol, what it does is it makes sure that all of the information that's being sent out over IP across the network using routers, it verifies that all of the packets that make up the data actually make it to the destination and are reassembled correctly. Because if you have large file sizes, like if you're sending a picture across the internet, well, that's going to be several megabytes. But we don't send full pictures across the internet. Instead, we break it up into ones and zeros. We package those up, and then we push them out in small packets across the internet as little tiny chunks and little tiny pieces. Well, TCP, it's responsible for making sure everything gets chunked up nice and neatly, everything gets addressed appropriately, and that it knows how many chunks there are that make up that file, and then it starts chucking those chunks across the internet. And then on the other end, the receiving end, TCP makes sure that it pulls in all of those packets, reassembles them, and if any packets are missing due to breaks in the network or bad paths, then it can make a request back to the sending system and ask for the missing packets. And then once it's got all the packets together, it'll put them all together, and then we suddenly now have a picture on our computer. So the transport protocol is extremely important. It's what verifies that all of the data we sent, we actually get on the receiving end. Sessions, we're not going to go deep into this, but what sessions are, it's all about remembering what happened with the last request that a computer sent. Normally, all of these layers, including some of these layers up here, they don't really remember what happened last. They simply process and then forget and move on to the next thing. If we want machines to remember what happened last in order to have context for what is happening now, we need to make sure we use some form of session in order to do that. Now the presentation layer, this would be encrypting a layer, or the ASCII2 for characters, or images like PNG or MIDI for music. That's what this layer is there for. It's for handling this type of information going across the network. Then the application layer, this is the big one. This is the one that we're going to be using when we create Express web applications and Express APIs. And that is because we will be primarily using the HTTP protocol, which lives inside of that application layer within the OSI network model. And HTTP stands for the Hypertext Transfer Protocol, which we spoke about when you learned about HTML, because HTML is hypertext markup language, and the documents that we're sending across the internet are hypertext. Therefore, you can see that the Hypertext Transfer Protocol, it is all about sending information across the internet in the form of hypertext. So we're talking about HTML documents. And of course, nowadays it's become more complex than just HTML documents because we send a lot of stuff across the internet. But this is the primary protocol that we use in Express to send and receive data across the internet in our web applications and our web APIs. This is why it's important to understand just how complex the internet is and how complex networking is, and how this OSI model is actually what makes it possible by creating abstractions and providing functionality for us to where we can use a framework like Express to build full-blown web applications and web APIs to do really complex things across the internet that if these things didn't exist, we would not be able to do. So give it up to networks. Networks and the network layer, extremely important in everything we do as web developers. Other software developers that focus solely on desktop applications or solely on graphics applications or stuff like that, they don't really have to worry about how the internet works, and they don't really have to know how all of this stuff functions because they don't depend on it. Web developers, our world is the web, which means our world rides on networks. And understanding the network system and the 7 layers of the OSI model, it's really important for you as a web developer. So make sure that since this was a really high overview of networking and the OSI model, that you take the time to dive in deeper and really read about it, really begin to understand how networks work.